Welcome back to those of you who are joining us for our second session of GED Day, and welcome to those of you who are joining us for your first session of GED Day. My name is Amy Ferrari. I am the Director of the Adult Training and Development Network, also known as ATDN, and I'll be serving as your moderator today. All of our sessions today are going to be recorded. All of the materials, slide decks, presentations, everything will be made available to you after GED Day. It will be sent both by email, and then we also do post it on the ATDN website. So if for some reason you don't get it in one version, you can always check the website for all of the information. I just ask that you give me a little bit of time to get that put together. So hopefully the beginning of next week, and we'll try to have all of that posted up for you. Certainly feel free to post any questions that you may have, comments in the chat. You can also unmute yourself and participate as well. So I'm thrilled to introduce today's second session, which is Sensational Science Instruction, certainly a tongue twister. Our presenter is an adult education consultant with more than 30 years of experience in adult basic education. He has served as an ABE, HSE, and AHS instructor, program administrator, instructional coach, and professional development specialist. He is the author of Writing for the GED Test, Book 4, and has contributed to adult education publishing with New Readers Press and McGraw-Hill. He currently serves as the co-aid professional development coordinator as well. So I'd like for you to join me in welcoming Stephen Schmidt, and thank you for presenting to us today. I'm going to go ahead and turn it over to you, and I will post in the chat a document that Stephen has requested as well.
Well, Amy, thank you for that very kind introduction, and appreciate you having me back again for GED Day. I think this is the third year, I think, that I've been back. So it's
I
always
think
good to
so. We love
it's always good to
having
be
you.
invited back.
Thank
Always
you for
good to be
coming
invited
back.
back. Well, welcome to our session on sensational science. And this is one of my favorite webinars to do, or face-to-face sessions to do. Know that science always gets the attention that it could get or should get when we're talking about instruction for the GED. So I am expecting that you'll come away with some resources and some thoughts about teaching science, which will make you feel more comfortable teaching science. And I'm looking forward to working with all of you today. I've learned so much doing webinars from things that people say when they unmute or in the chat. So please don't hesitate at all to share, and I'll be calling on those times to share throughout our session today. Amy mentioned a handout, and she's going to put that in the chat if she hasn't already, and thank you for that. I will refer to this many times. My basic philosophy with presenting is I don't like to read bulleted PowerPoint slides. I know some people like to do that, and more power to you if that's what you like to do. I prefer to give you the notes that are on the slides in a handout, and that way you'll have those to refer to in the future as well. So that's my presenting philosophy in a nutshell. Although he says that when there's bulleted points on the screen right now. But anyway, these are just the objectives for today. Our objectives are three, one of which is we're going to talk a little bit about how we approach science instruction. We'll also talk about some teaching methods that we could use to improve student scientific understanding. And you will have resources both in the handout that I'll give you, and there'll be a few links that we'll share as well that really show some great science instruction. So thank you, Amy, for putting the handout in the chat. And yeah, go ahead and please download that, because I will be referring to various page numbers, which you'll find at the bottom of the page. So yes, please grab that handout. Well, let's go back in time. And let's go back, let's see, what year would it have been? Let's go back to 1980. And I remember being in a science class. I think this was in junior high school, so I'm dating myself, because I remember it was 1980 because Mount St. Helens had erupted. And this was an amazing event that had happened. And we didn't talk about it that in science class at all. Science was really more of here's a bunch of notes that we're going to tell you about the endoplasmic reticulum. And I do like to say endoplasmic reticulum, but that's about all I remember about science from school, except my hand hurt a lot because I was taking a bunch of notes and I needed, even though I was only, a young teenager at the time, I probably needed some arthritis medicine to uncramp my hand with all the note taking that we did. And so, Steve, what was your big takeaway from science class? The big takeaway was science is just a bunch of facts to be memorized. And that was the view that I held through high school, through college, and out for some years into my teaching journey. Carl Sagan, if you're of a certain age, you'll remember Carl Sagan. If you're a younger age, you'll have no idea who Carl Sagan is. This man was big time back in the 1970s. He had a number of specials on PBS, and he was famous for saying billions and billions. One of his other famous quotes was, excuse me, science is a way of thinking much more than it is a body of knowledge. And I sure wish my junior high school science teacher had taken that and adopted it in their classroom. But Carl, I think you are right on the money. Science is a way of thinking much more than it is a body of knowledge. Too often, though, it's taught as a body of knowledge and not as a way of thinking. So I'm hoping to change your thinking about scientific thinking as we go through. And maybe your mind's already been changed, so it'll be easy to do. Let's look at page 2 of the handout. And page 2 is on the, well, I have a paper copy. You probably have the digital copy. So flip one page over. I'll flip to the inside page. And we're going to take a look at this thing called Thinking Scientifically. And this is from a blog post that I found. Whoops, we're not going to do that yet. From a blog post that I found that I really think is an awesome way of looking at science. And so I'm at the top of page 2. And let me read this for us. It says, How to Think Scientifically, top of page 2. If you don't have the handout, Amy will make sure you have it. So, science, stripped down to its essentials, again, we're on the top of page 2, is just a method for figuring things out. I like that. That's real accessible. You look at a situation, you come up with an explanation, you try to see if it works. If it does, great. If not, try something else. Repeat until you find an explanation that works. This does not demand a complicated skill set. It's not really much more than you need to be a functioning adult in modern society. And most people have at one time or another used exactly this procedure. If you've ever cooked without a recipe, anybody ever cooked without a recipe? You have the mental skills needed to be a scientist. You come up with new dishes in essentially the same manner you solve the scientific problem. You take a guess that putting some ingredients together will be delicious. Then you do it and you taste to see if it's right. And if you're not, you throw it away in the trash can and you learn and you try it again. That's the scientific method right there. And millions of people have done it at some point in their lives. If you've ever repaired anything, a car, a dripping faucet, and a blown fuse, you have the mental skills needed to be a scientist. And that doesn't mean that you solved it successfully. I'm laughing because I had to call the plumber last week to fix my do-it-yourself plumbing that I did in both of the toilets. But he said I did a pretty good job for an amateur, so I'm going to own that. I'm going to take that. And he was much happier when he left with a lot of my money. But anyway, you fix problems in everyday life in the same way that you attack scientific problems. You make a guess as to the source of the problem. You try the appropriate solution for that problem and see if it worked. That's how science works. And millions of people make their living doing this without ever realizing they're thinking scientifically. Love it. Thank you, Chad Orzel, for your blog on the Uncertain Principles blog. I would love to react to this. I would love for you to react to this too. I want to react to it as well. I guess I've already reacted to it because I like it. But I would love for you. I know some people have already been in the chat and have introduced yourself, and I was saving the chat for this time. So if you haven't already, please introduce yourself, and then you can also react to the article and or the blog post, I guess, if we want to be technical. what was your take on this? So you could really answer in a couple different ways. I've got a suggestion there saying, would sharing this with your students help to kind of demystify science? We think a lot of times about science as, we've got to wear a white lab coat and it's all, these people are brainiacs and geniuses to be a scientist. And we're all scientists when we try things and to see if they work. We are all scientists. We shouldn't wear the white coat. So you can react to that question. Would this help your students demystify science reading this blog post? Or you can just, if you have another thought on this blog post, your thoughts are welcome. And you can unmute. You could be the brave person who breaks the ice and gets the ball rolling and is the first person to unmute. So the floor is open for chatting, for unmuting, and I will try to be quiet while that is happening. All right, let's see. Cesar says the first step is to present science in their daily life, daily application. Love it. Lisa thinks like a scientist. Okay. Thank you, Lisa. Oh, we got a smiley from Lisa. All right. All right. So who else? Again, the floor is open. If you feel especially inspired and you want to unmute and talk, you could do that. Chelsea's liking it. I'm trying to unpack Chelsea's last name. Grabarek? Am I close? Grabarek? Hopefully I'm close. My apologies, Chelsea, if I didn't quite get it. Oh, spelling it phonetically. Love it. Grabarek. I never would have gone that way. Thank you. Thank you for the phonetics. Grabarek. Okay. Yes, Annette does use the silence daily to make connections to students. Wonderful. Annette, are you feeling brave this morning? Would you mind unmuting and telling us more about how this looks in your classroom? Or maybe Annette is using the the district laptop that was just upgraded to Windows 98, and maybe the audio is having some issues. Yeah, I got you. No problem, Annette. No problem. But we'll take your comment once your difficulties are resolved. But thank you. So thank you for everyone who has reacted so far. And I'll keep the floor open for another few seconds here. Translate to a slideshow. Daniel, I like the way you're thinking. I like the way you're thinking, Daniel. Very cool. Well, thank you everyone who responded or is still maybe still typing. Maybe they're having a lengthy response. So I hope this helps. I hope that it demystifies because I felt, for years when I was teaching students on a daily basis, a bit always intimidated about teaching science because my science background was not so great. And I think I made a C in college biology and all these things. But this has really helped me to better understand what it really means to think scientifically and what it means to be a science teacher. All right. All right. Let's see. I need to tell you a story. So look closely at the screen. I realize this is not the greatest picture, but you will see a picture of my science teaching mentor. This is a man named Jeff Goodman. And I first met Jeff in 2007. I went to a week-long teaching institute at Appalachian State University, where I actually went to work there 3 years later. But before I went to work there, I met Jeff at the summer institute that they had for adult education teachers. And Jeff, in his session, never met him before, never seen him before. He walks in the room and he said, I want to do a demonstration here and I need to empty my pockets. So he empties his pockets. And then he proceeds to ask for a volunteer gives the volunteer a bottle of water. And he says, I want you to put this in my mouth in a minute. And so volunteer standing there holding the water. He does a headstand on the table in the front of the room. And he proceeds to have the volunteer give him the water, and he drinks the water while he is standing on his head upside down in the front of the classroom. He takes one big gulp. You can see the water's gone down. He takes the another big gulp of water, and the water goes down even further. He's drunk about half the water in the bottle. And he's saying, how is this possible? How can I, when I am upside down, drink water and it is not spilling all over the table? And there was a buzz in the room. I don't know, there were 50, 60 people in there. There was a buzz. There was conversation. People were wondering how this was possible. And he used this to illustrate the concept of peristalsis, which is those muscles in the esophagus that function independently of gravity and are able to move water against gravity because of the way these muscles contract through the esophagus. And that made a huge impact on me. That was 18 years ago, and I have never forgotten that. Jeff is an amazing teacher, and you're going to get a chance to see him teach today, which is even more awesome. I'm a big fan of modeling, not runway modeling, but modeling, watching great teachers teach and modeling my teaching based on great teachers teach. I had a wonderful opportunity to participate in like a great teacher symposium when I was in graduate school, and actually got a chance to watch really good high school teachers teach, and went from classroom to classroom and got a chance to watch them teach, interact with them, and do that over time. And I learned so much about teaching through that experience. I think when we can find a great mentor and model practice, of course, we need to be us adopting their practices. We can't just totally imitate what they do, but we can imitate the great things they do. So we're going to watch a teaching demonstration that Jeff's going to do here in just a minute. Couple questions I'd like you to think about, please, as you're watching. First of which, how does Jeff generate excitement about science? Because a lot of times people think science, oh. Um, how does he introduce a mystery? I already told you about how he did it with the peristalsis. He asks questions. What do you notice about the way he asks questions, how he asks questions, the sequence of the questions? And just watch. Anything else that you see that strikes you would be something to we will unpack this later. We will debrief this experience in a bit. Jeff does things called human wonder research, and we're humans and we wonder about things. And he's going to do a demonstration here, which is easy to do. I've done this with learners before, very easy to do. And the thing that he's gonna ask is what's causing the soy sauce packet to move. So let's see here if this will work. And I've already shared the sound, so hopefully it'll go. But let me know if you're not seeing this or hearing this. Here we go. So you've got what you're supposed to be watching for. Let's see what Jeff does here. Okay, we're gonna skip that part. There we go. How we doing? We see and hearing?
You can see it, but not hear it.
Okay, will you hold on to the hairdryer?
There we go.
And notice I'm just going to tie these together. I'm not even actually plugging them in, but you'll see that I don't need to plug it in for it to work. So I'm just tying that there. And then I have one of those old wired computer mouses, and I'm going to tie that in too. Okay, will you hold that one? Just hold the end of it. No, yeah, there you go. So I'm just going to tie this together here. Normally you think of wires, the insulation being a problem, but in this case it's not. All right, now I should be all set up to go. I need to get you all positioned right, so I'm going to slide you back just a little bit. And would you point that hair dryer up kind of at that light right there? Excellent. All right, and want you to double check. All right, yeah, like that. Okay, I want you to point that end of it sort of back up at that same light, right up there. Okay, excellent. Okay, and I've got the mouse. And the other piece of it, let me check the switch on this. Slide that all the way to the top. There we go. Okay. Now, right in this bottle, I have some soy sauce and some mustard from a Chinese restaurant, and they're floating in this bottle, okay? And what I'm going to do here is I'm going to show you that, see, I'll stand in the middle so you all can see, that this, yeah, there we go. Okay. All right, now with your left hand, once I get it down to the bottom here, go ahead and cover where the air comes out of the hairdryer. Okay. Okay, now uncover it. Okay, so let's just see for a second. Keep them both pointed there. You know, keep it there. Now you turn your switch off and turn it back on. Okay, so this is kind of a mystery, right? Right. Another thing that's like science, but it looks like magic. Like, what could possibly be going on? So, what are some of the options? What's the science that underlies this? Yeah.
The light could be like producing electricity.
Light, that's a great idea, right? Because we know that, like in solar panels, light produces electricity. We can get a force out of that somehow. So what else?
Like the electrical current, where like everything's attached, it's like to tie everything up, so it's like all.
Yeah. So somehow, even though this has insulation on the surface, somehow there's an electrical current. Okay. Let me have you all go sit down. Give them a hand for a second. They've done their job. Don't worry. I'm not done explaining this. I just, here's the thing. A lot of times people will show you stuff on the internet and something will look like it's happening, like cell phones are making popcorn pop or something like that, right? And it really looks true, but you're not paying attention to some key element. So look at my hand carefully, okay? And then just notice what's going on. So why were you thinking that it had to do with why were you thinking that it had to do with all that other stuff? The hairdryer? Yeah. I'm tying it up, and oh yeah, and I've got to get it just right. You notice, and when you see stuff on the internet where people are trying to trick you, they are often going to do that, right? We got to do this, we got to get this. Notice I checked the switches. Oh, and then did you notice how at first I was like, oh, it didn't work, and then I got him to reposition it. Like that's all part of getting you to think something. And now, I want to suggest something though. You're seeing the magnetism, right? But have you been noticing my voice? Okay, I'm going to do it more extreme, okay? Just notice that you can change your voice. We're going to talk about sound in a little bit. And then you can have a much lower pitch sound and a higher pitch sound. Now, I was changing my voice before, but not as extreme as I'm changing it now. And so you'll see that, in fact, now why did you think my ring has nothing to do with it, right? So why is it that you thought that my ring was the thing? After that, you were so sure it was my ring. Oh, yeah, it's his ring. It's definitely his ring. Yes. And before I take your question there, what I'd like to do is have you all make a nice high-pitched sound. Ready? Keep going. Low-pitched sound over here. Okay, now, you can see that we tested it out, and we can see how it's working. What I've always wanted to be able to do, though, I thought it would be really cool if I were able to just, like, without speaking at all, if I were to come up with some way where I could just, like, look at it and just go, like. Some things aren't possible. You know, it's like I just had this idea that maybe you'll come to college here and you'll be in my class, and I'll finally have figured out a way where I can just, like, you know. Come on up here. Okay. Now, I've been squeezing the bottle the whole time. Go ahead and give it a squeeze so you can show people how that works.
So, it's just the pressure change.
Now that's great. Pressure change, but why does the pressure change make that one sink?
done this before with like a paper clip and stuff, but I got no idea.
Okay, well, that is the first place to start in science. I've got no idea. Why do things float and sink? What makes them float and sink? Wait, yeah, in the back. Density. What does density mean? Somebody give me. That's just a word. Somebody give me like a way of thinking about it. What is it? Wait a minute. The weight, but like. Hang on a second. I just want to play. I like your idea with the air, but let me play out this idea of weight. People, a lot of little kids will say, light things float. And I'm like, yeah, like boats. You know, like boats are really, like a big battleship is really heavy and a pebble is really, really light, but a pebble sinks and a battleship floats. So it can't just be weight. You said something about air. Somebody said the word density. What do you got? Ah, so it's a relationship of volume to weight. Now, here's the thing. This thing is sinking, which must mean I've changed the relationship of volume and weight. In fact, density is how packed together the material is in it. It's another way of thinking it. So how could I possibly pack together the stuff in there? Why does squeezing it pack it together? Yeah.
Buoyancy.
Okay, buoyancy is another word. What does that mean?
It's like, it's again with your analogy of the battleship, it's the air inside of the container.
Okay. Come up here for a second. I want you to see if you can see a little bubble in the top of the packet. It's kind of hard to see in there, right? Now, when I squeeze this, what do you think happens to the bubble?
It shrinks.
It shrinks. It's like I've made this thing more dense temporarily. The bubble has gotten packed closer together. When I let go, the bubble expands, right? Stay where you are, and I want to just show you something, okay? Hold on to that. Okay.
Okay, I could watch Jeff teach all day, but we have some other things that we need
I'm not going to let it
to do.
change volume.
Okay.
Right now we've
Okay, thanks, Jeff. Thank you, Jeff.
packed the air tighter together. As soon as
Okay. Let's try that again. Okay. Where have we gone? There we go. All right. So let's go back to the PowerPoint. There we go. Okay. So essentially, what we saw there in Jeff's teaching demonstration was he did a well-known science experiment called the Cartesian diver. And as he did explain, that pressing on the bottle, which he did, he was doing all this other shenanigans with the mouse and with the surge protector and all this stuff and with his voice and all this stuff. But essentially what moved it was the fact that he had his hand on the bottle and he was squeezing it. And that caused the packet to become denser and then too heavy to float and causing the packet to sink. You can very easily replicate this. You go out, get a Chinese meal with a soy sauce packet, and he just had an ordinary 2 liter bottle, take the label off, put water in it. All was in there was water, and it's very easy to do. I've done this with great effect many times with learners over the years. Very, very easy to do. No white lab coat required to do this. Well, let's go back. So we've looked at the scientific principle, demonstrated, modeled. What I would really like to focus on even more is Jeff. And Jeff is Jeff. I can't be Jeff. We can't be Jeff, but I can adopt some principles of the way he teaches. I could be me being Jeff, so to speak. You could be you being Jeff. So let's do this. Let's please either chat or again, the floor is open for unmuting. And we're all friends here. No one is going to ridicule your comment. We will all provide supportive things if you unmute and talk. How does Jeff generate excitement? How did he introduce a mystery? What did you notice about the way he asked questions and handled answers? Or is anything else that you noticed about this? So the floor is open, please, and thank you. And Steve is modeling wait time here as we're waiting for good stuff in the chat. Oh, do I hear something?
Hi, Jeff. This is Lisa. I mean, Steve. I
I'm
noticed
I'm
that.
proud to be confused with Jeff anytime, Lisa.
I,
Thank you.
I noticed that he involved the students, and they were asking, he was having them participate in what this looked like a magic trick to begin with. So that was one way to generate involvement and engagement.
Absolutely. Thank you so much, Lisa. And look, Lisa unmuted and talked, and she's still alive.
He also created a sense of anticipation, which I thought was really, really well done.
Thank you, Cheryl. And that was very well said. Let's see, Jane says in the chat, questions were not only asked of everyone, but he demonstrated that each student had value. Loved it. Love it. And Amina said, makes it look simple. Thank you.
Amy shared a question as well, but it came to me specifically because we were chatting separately. But she said he adds a lot of extras without saying much. What is next?
Yeah, thank you. Great comment there. While we're waiting for other comments to come in, one thing I love about Jeff is he always posed the question, who is the enthusiasm engineer in your classroom? Who is the enthusiasm engineer? Oh, and Mark was reading my mind and he said, excitement breeds excitement. Oh, Mark, beautiful. He's clearly passionate about his craft, and that's the hallmark to exciting classrooms. Mark, that was beautifully written. Wow. Very impressive. Very impressive. Yes, could not agree more and could not say it as well as Mark did. Beautifully said. Beautifully said. So that really got me thinking, and if we're not, even though science may not be our thing, um, we can still be excited about being in the classroom, and we can still be that enthusiasm engineer. Because if we're going to get up there and like, oh, here's the class today, we're going to talk about science. I'm really excited. How about you? Of course, our students who are already facing many challenges about being in the classroom will even we want to be there less because of our lukewarm attitude there about things. Um, let's see, waiting for any other comments. I loved the way that he handled that young man. And he was doing a demo. These were middle school students. He was doing the demo and he asked the student about buoyancy and why the packet didn't go. And the young man said, I have no idea. And instead of making him feel badly, he said, that's where science begins when we have no idea. So I love that. He took the answer and he still made a great teaching example from it. And instead of making that young man feel badly about not having being able to explain that, he was able to say, hey, we are all in that same boat. And that's what science is all about. Loved it. Anyone else want to unmute? Okay. Oh, we got another thing in the chat here. Yeah. Oh, yes. Thank you, Daniel. Because he was trying to, instead of trotting out the vocabulary word, what's it mean? And how does it look? How can we really understand it? Beautifully. Good, good, good. Man, we're awake this morning. This is great. I'm so impressed. So impressed. Okay. Jeff says this, think of science as a verb. You have to do it. And I love it. And there's many easy ways that we can do science, even in our adult ed program that does not have probably a fully equipped chemistry lab. I'm sure. I'm sure if you do, wow. But I would probably bet that you do not. But we'll talk about ways that we could make that work as we go on through today. By the way, Jeff's teaching methods work well. One day a week, he volunteers in his wife's third grade classroom in a school in Polk County, North Carolina. Polk County, North Carolina is in the middle of nowhere between Charlotte and Asheville. Low socioeconomic status district that you would think would be among the worst performing districts in the state. It is not. Jeff has really got teachers there thinking and doing some incredible things. what I was just looking at the third grade. So in North Carolina, they take an end of grade test in science in third grade and eighth grade. In Polk County, third graders are typically either first or second in the state. Some years they'll trail Chapel Hill, Carrboro, where the kids there are sons and daughters of professors that teach at Duke and University of North Carolina. But little old Polk County sometimes beats those students because of the way that Jeff is getting these young people to think about science and love science. It's incredible. It is absolutely amazing. You can see 15 percentage points over the state average. Incredible. All right, let's shift gears. So I did work as a consultant for the GED testing service a couple years ago, and I learned several things during that experience. They did also some studies, and they found out where students had knowledge gaps. This was several years ago. One of the knowledge gaps they determined that students had were that the students had difficulty analyzing scientific and technical arguments and text-based information in trying to reconcile multiple findings based on the same data. If two people look at the same data and the one says one thing, one says another. And so that was a skill gap. So we're going to look at some ways maybe we could help with that. And we're going to look at science information being shown visually, whether that's in a table or whether that's in a graph. I love to think about the ways that graph tell a story. And I do one of my favorite techniques is the slow reveal graph. I'm not going to do a slow reveal graph today because I'm sure Connie has probably demonstrated it multiple times in PD. And so I cannot do it as well as Connie. But I love slow reveal. But graphs essentially tell a story. Maybe the story here is Steve is out for his afternoon walk, and he's walking and you can see his heart rate there toward the lower end of the scale. But suddenly there's a bear. Steve has got to get the heck out of Dodge to avoid being eaten by the bear. So he's starting to run and his heart rate is going to go up. Graphs tell a story. It's just up to us to figure out what the story is. And there's lots of clues with graphs that help us to do that. Well, let's get in and look at some scientific data and see if we can reconcile why data sometimes will get interpreted differently. And this is especially important in our modern day life as politics plays a role many times in how data is interpreted now, especially on the national level. But I'm not going to go there today. You're probably thinking some of the same things. But anyway, let's start with this. I want you to take a guess, please, in the chat. Please don't Google this. Please don't Google this. Please don't have AI tell you the answer. Just guess off the top of your head. What do you think are the leading sources of electrical power generation in the US? What do you think? No one's going to make you feel bad if your guess isn't, exactly right. We're just trying to see what's there, trying to get some background knowledge going. So just put in the chat, please. What do you think? Leading sources of electrical power generation in the US. All right, thank you, Amy. Cynthia, thank you. All right, Mark, Daniel, Cheryl. All right, we're getting some guesses across the gamut here. While the guesses are coming in, I would just like to say that power generation is a complicated issue. There is no such thing as a free lunch. Every source of power generation, even the ones that are non-fossil fuel have issues. Wind, solar, they all have issues, and there's no free lunch here. There's challenges with every single thing. So that's one thing that we'll keep in mind as we do this. Like, for example, people think, oh, wind power, it's clean, it's great. Well, there's challenges with wind power. And actually, I'm not going to say what they are. Put in the chat what's some challenges with wind power, and is wind power completely clean? That's something to think about. I won't say anything. Put it in the chat if you've thought about wind power or read anything about wind power. What might be some challenges there? Okay. Well, here we have a very interesting set of data here. And this is what may cause our students a little bit of confusion because this graph that we're seeing is a bit different. And we're seeing natural gas being represented by a light orangey color. And I'm not good with non-primary colors, so I'm going to do the best I can. Maybe a light gold or something. Black is represented coal. That I got. Nuclear is like kind of a pinkish. Wind is green. Solar's yellow, I guess, as it should be, and other is kind of a grayish. So, but we can see over time things have changed a little bit. And I know at least one person said natural gas, and good for you. Coal is still pretty significant there at about 20%. And I know at least one person said coal. Nuclear got a very bad rap. If you're of a certain age, you remember 3 Mile Island, and we all thought we were going to die. It was a bad situation back in 1977. I know they've done quite a bit of work to make nuclear safer. And I know Bill Gates, who's a pretty intelligent guy, seems to think there's a lot of promise with nuclear, but there's still a lot of fear about nuclear. And I have no dog in the fight. I'm happy when I turn the light switch on and it works. And if I turn the heater on and it works, I'm even more happy. So something to think about here with sources of electrical power generation. But natural gas, there's been a lot of work with tapping natural gas resources in the Permian Basin out west and using other new techniques have helped to unlock some of that natural gas that maybe 20 years ago we were not able to get. There's been a lot more domestic production of a lot of energy in the United States over the past 10 years, especially. So, one thing about coal is still a leading generator of power, roughly about 20%, as we saw. And people talk a lot about clean coal, clean coal, clean coal. Well, clean coal has challenges as well. Coal, when it comes out of the ground, is not fit to go into a furnace to be burned, to be used for power. Coal needs to be clean. And so it comes out of the ground and it's got stuff on it. It's got soil, it's got dirt, it's got other contaminants on it. And so they have to wash it. And typically they use water and they use some other chemicals which have names that have 25 letters in them with many consonants. And those things will clean coal well, but they will also hang around after the cleaning is done in the environment. And so coal, when it's cleaned, produces something called coal slurry as a byproduct, which has its own challenges. I'm going to show another video, and I do have, okay,
In West
and hopefully,
Virginia, coal is
can we
king,
see and hear this?
not to Billy Salmons.
See, come and look at this water. It come out of my water heater.
Salmons has sued the Massey Energy Company, claiming they turned the water in his well black and made him sick.
Here's some that these definitely.
He takes 20 medications a day for everything from diabetes to dementia.
It's killing people. We've had a lot of people die. Everybody in my family has been sick from it.
Salmon says it's all because of the coal slurry that was pumped into the ground, contaminating his water. Coal slurry is a byproduct, the unwanted leftover from processing coal before it's burned to produce electricity. Usually it winds up in slurry ponds like this one. West Virginia has 232 slurry ponds, more than any other state. They're usually high in the mountains where coal was mined, and they rarely fail. But when they do, people living in the hollows below can be wiped out. There have been 6 pond failures in West Virginia in the last 25 years. One of them, the Buffalo Creek disaster in 1972, killed 125 people. To avoid such disasters, some coal companies pump their slurry underground, but that can contaminate drinking water, or so says Billy Salmons.
And we drank that stuff, cooked with it, bathed in it for almost 20 years, what you could say 20 years.
Researchers found high levels of cadmium and manganese in Salmon's well. Hundreds of West Virginians, sick like Salmons, are suing Massey. They all live below coal ponds or near injection wells. These lawsuits and a recent federal court ruling that halted mountaintop mining in southern West Virginia have coal operators worried.
The problem with it is that all of these decisions affect all kinds of mining. It's very troubling, and we know that it's going to have an impact. It's very difficult to quantify.
Though change will likely come to coal country, this fossil fuel is still one of the cheapest and most plentiful forms of energy, producing about half the electricity used in the United States. Nobody expects it to go away anytime soon, especially not in West Virginia. For This American Land.
Okay, so that's a little sobering thing to see about coal slurry. And if you look at this, what you see on the screen very carefully, you can see they showed slurry ponds where these companies will put the leftover, the slurry after the processing is done in, and you can see it looks like thick, black, tarry, an oozy substance. And my heart breaks for that poor gentleman and his neighbors who are dealing with the effects in their drinking water, or did deal with the effects in their drinking water. I was just thinking there was one time famously in the state senate in West Virginia, a senator got up in front of it and he had what he said was a glass full of coal slurry, and he drank it to show that it was, even if you drunk coal slurry itself, it wouldn't hurt you. And I'm whether he actually had coal slurry in the glass and whether he died later, I don't know. But he did that, of course, to show that West coal mining is huge in West Virginia, leading economic producer. So that is definitely something that many people in the state are still employed in that industry. So these slurry ponds, we did see how they will stand up as long as their boundaries are remain intact. Everything's okay, but as we saw, sometimes these ponds do fail. And they mentioned that one disaster in the early 70s that killed a number of people. And so either pumping the slurry in the ground where it could potentially impact the groundwater, or putting in these large slurry ponds are byproducts of coal cleaning. Join me, please, on page 6 of the handout, and we have some data that is about coal slurry storage and health effects. So we've seen the debate in the video. We know about what coal slurry is, where it comes from. And so in this data in 2008, massive coal company, get it? Massive coal company, began to put coal slurry in 4 abandoned mine shafts near Prenter Hollow, West Virginia. In 2010, local residents began complaining about the quality of their drinking water and noticed increases in health problems such as cancer, birth defects, and headaches. And I'm on page 6, third paragraph down. The chart below lists results of water tests done near Prenter Hollow every year from 2007 to 2011 for common chemicals contained in coal slurry. A lot of C's there. It says, look at the evidence to show whether the coal slurry dumping and the abandoned mine shaft cause an increase in harmful chemicals in the groundwater. So I would like for you, please, to take a look at this chart here. It starts in 2007, moves to 2011. You can see that across the top and across the side, we see these different heavy metals or organic compounds, including such favorites as chromium, selenium, and 4-chloroilline, which I think I murdered that, cadmium and antimony, all your wonderful heavy metals are there. So look, now, word of warning, of course, with students, we've got math now because we've got decimals here, so we may need to do a little bit of decimal review. And what does it mean when we've got 0.000? And these are all represented. We see a little asterisk and it says these are parts per million of these various compounds. And so what I would like for you to do, we're just going to do a simple notice and wonder. And so what do you see? What questions does this bring up? And just keep in mind, 2007 was prior to the coal slurry pumping in abandoned mine shafts. 2008 is when they started doing it. So we see then from 4 years after that fact. So please, if you would, in the chat, unmuting, anything you notice, anything you wonder about the data that we are seeing here, and read from left to right as we progress during that 5-year period. Oh, and thank you, Daniel, about your comment about wind power and the inconsistency. Yeah, and wind does have those turbine blades have a life and they do not last forever and they are not recyclable. Then I've seen pictures of places where they're just dumped here and there. Let's see, Jane says all have increased in the past 5 years. Oh, Cesar has gotten out his calculator. Wow. Let's see, barium. Barium. Yeah, I think you're spot on, Cesar. So seeing some noticing. Any questions? Oh, any wonder? Any questions there? People are thinking deeply, and deep thinking requires time. So we're not going to rush it. I'd say Jose says something happened from 2010 to 2011 because yeah, we do see things like mercury's increased 3 or 4-fold. Arsenic's about doubled. A 4-chloroaniline has gone up 5 times. Barium's experienced a huge increase, so that's interesting. And let's see, what are they doing to solve the problem? That's a good question, Jane. And Lisa said, are these found in coal? Oh, Lisa, you've asked an excellent questions. These are byproducts of the cleaning process. So they could potentially be coming from the coal, but they're also coming from the chemicals used mixed with water that are cleaning the coal. And most of these are coming from that process, the chemicals that they use along with the water to clean the coal. Let's see, Mark says what to stay consistent when the others are rising. Those are really good questions, really deep questions. And this is something all of our students are capable of doing this. Notice wonder, I think, is a great protocol because everybody can notice them things. We are hardwired to notice things and notice changes. So that's definitely something that all of our students are very capable of doing. Thank you, everyone who has taken a look at this and done the notice wonder technique. So now we've got some different findings here. And so let's look at these and let's see if we can figure out why these same findings, why these two organizations have come up with different conclusions. So here we go. So Drake Scientific has taken a look at this data, and Drake said the chromium and selenium levels have remained the same over time. The other metals or compounds show a small increase. The increases can be explained by errors in the collection and analysis process and natural leaching into the environment. And Drake Scientific was hired by the massive coal company. And see what Steve did here. Steve put this stuff together, but there's Massey Coal Company, so I changed it to Massive Coal Company so I wouldn't get sued. Kimball Analytic said, so another data collection agency's come in. They've looked at things. Another consultant has come in and they've looked at things. That's a better word. So Drake says it's collection error. This will happen naturally over time. Kimball says of the 8 substances shown in the table, 6 show large increases: mercury, arsenic, 4C, barium, cadmium, and antimony. This proves the view that coal slurry dumping in abandoned mine shafts caused an increase in harmful substances in the groundwater, which may be impacting local residents' health. And Kimball was hired by the West Virginia Concerned Citizens Group, which is a health activist group who are concerned about environmental factors that are affecting people's health. So, how can we reconcile these two different findings? And once again, the floor is open for chatting, for unmuting, please, and thank you. How can we reconcile? They're looking at the same exact data. I know some good stuff's going to come, and feel free to unmute.
Um,
Tell us how you feel. Lisa, please go for it.
yes. Well, they obviously both have biases on how they interpret the data. What Drake shows as a small increase, I think someone else pointed out that it was over 360%, which, there's taking a little license with the word small. Um, and the other one obviously wants to get rid of the coal slurry and is showing that undoubtedly this data points to health issues.
Well, Lisa, thank you. Very well explained. Thank you. Yeah, and Cesar mentions Erin Brockovich, which who was a activist, and I forget what she was being an activist against. Might have been nuclear, I don't remember, but maybe Cesar remembers what she was doing. But yes, that was certainly, I have never seen that movie, but her story is well known. Thank you, Cesar. We're on top of it today. Got the calculator rolling. Good comments in the chat. So please, other comments, please, please, and thank you can come in. So, and I love that Lisa mentioned the word biased. And like it or not, we are all biased. We're all shaped by our past. We all have biases toward or against certain things, some of which are conscious and some of which are unconscious, and some of which are influenced by money. Definitely, for sure. I remember when I worked at the university, we had a young man from Nigeria who was serving as our as an assistant, and he also worked in a lab, and they were doing research on watermelon, some watermelon extract and its effect on health. And the study was funded by the Watermelon Growers Association. So I wonder what the data turned up. I wonder. Follow the money to see where things are going. This is true in politics. This is true in science as well when we have studies done. Any other comments? Thank you for those who commented. And this dragged the lawsuit that they were mentioning in the video we saw dragged on for a long time. And those who launched the lawsuit did get some type of a settlement, which, in the nature of many of these things, the company did not admit responsibility and people received a settlement, and it's all under cloak. We don't know exactly what it was. So, and it took years to solve. So it didn't get solved till 7-year lawsuit. They're finally settled in 2011. All right, what did I learn when I worked for the GED testing service? Well, sometimes we wonder what vocabulary students should know. That would be good things maybe to do some teaching that will help them as they prepare for the GED. And there is a little known but highly valuable resource called the Assessment Guide for Educators that's out there. It's been around since the test first came out. The new test first came out in 2014, has been updated frequently since then. And there is an assessment guide for educators in all of the GED subjects, and science has one as well. But in the appendix, it does highlight vocabulary. And I would think that would be some good words to make sure that our students know and highlight those as we go through our regular teaching, because that's what the test makers thought would be important. So, Appendix D in the assessment manual has some very valuable information. This is interesting reading also. So, especially if you'd like to get into the weeds with things, it's some good stuff. Okay. Here's what I would like to do at this point in time. And Amy's ready to do a breakout session. Now, before you panic, please, please, please. I know some people, when they see breakout, they run for the hills. Please, please, please don't do that. This is really your opportunity to reflect on what we've done so far. What I'm going to ask Amy to do in just a minute is to put you in a breakout room with about 4 or 5-ish others. And what I would love for you to talk about is just kind of there we go. Oops, went fast too. Just kind of react. Open forum, react to what we've talked about today. And this is also share best practices. What do you do in your classroom to help students learn science? So you can react to anything that we've saw and discussed. You can also talk about best practices that you're doing inside the classroom. Okay, very good. Well, welcome back, everyone. I know the breakout room that I was in, we had a good discussion and heard a lot of great things about Joan, and what a wonderful teacher that she was, Joan Bucko. So good stuff was shared there. So I'm thinking, we talk about science is not a body of knowledge, it's something that you do. And wouldn't it be great if there were, oh, maybe, I don't know, 11 simple, easy to do experiments that you could do anywhere, whether you have a well-equipped science lab, which no one in adult ed probably does, or you're teaching in the trailer with the broken whiteboard that is down at the end of the school where people are afraid to go. And you've been teaching there for years, but you have no resources, but it's great. And your students are learning and making progress. Wouldn't it be great if there's experiments you could even do there? Well, there are. I want to share a couple things else inside our handout. On pages 2 and 3, it's you're walking through the steps of the scientific method. And try to do this and create this in easy to follow language. If students may have certain exposure to the scientific method, and they've probably all seen the baking soda volcano and different things, but some have had more exposure than others. So this is kind of an easy way to walk through how we do the scientific method on pages 2 and 3. And it walks through the process of designing an experiment with water. How warm will water stay based on different insulators there, from thermos, plastic, or styrofoam. But wait, there is more. The star of the show is on page 4. And these were actually experiments that I shamelessly stole from Jeff Goodman, the gentleman that we saw teaching earlier. And so these, you can do these anywhere. These are corrections friendly, most of them. Probably all of, I would think most of these are corrections friendly as well if you're in that context. But you can see there on page 4, does adding aspirin to water keep flowers fresh longer? That may not be corrections friendly. Does the height from which a ping pong ball is dropped affect the bounce height? The insulator. How does activity? That's definitely corrections friendly, whether we're lying, sitting, walking, running. How does that affect pulse rate? The M&M activity, a slice of bread. How long will it take water to evaporate from different containers? Rolling a marble down a ramp, how does ramp height affect how far it goes? How does temperature of water affect out an Alka-Seltzer dissolving? Oh, and coins. Maybe harder to find a penny these days, but we could still do a dime, a nickel, a quarter, or maybe if we've got a dollar coin. And this is an interesting one because the tricky part there is really controlling spin. And how do we make sure that our spins are done consistently? And then what shape of paper falls the fastest? That's definitely corrections friendly. We definitely could do that one. So these are ways we can get students doing science, and it gets them practice with forming hypothesis and then going through the steps and recording data to see how that works. So you have those for some ideas, as well as an experimental design graphic organizer that you could use to go through if you were looking at doing one of these experiments or another one as well. So let's take a minute and reflect. I do hope that you've picked up something from what we've been doing this morning. And my goals were, I hope that you're thinking about science a little differently, or can help your students think about science, that it's not you're in the white coat and have to memorize a bunch of stuff, but it's that science is that which we do to solve problems. And I hope that you're inspired by seeing a great teacher teach and seeing the techniques that he used in order to get students thinking and get students excited and engaging with a mystery. That's a huge thing. I hope that you're seeing a little bit more about how we can analyze data and we can reconcile perhaps different conclusions from the same set of data and thinking about bias and thinking about who's funding experiments and this type of thing. Please put in the chat something that you'll take away from or a question or a comment from today's session, please. And while you're doing that, I'm going to say thank you, thank you, thank you. You've been a wonderful, wonderful group of participants today, and I really appreciate all the good comments in the chat and those who are brave and unmuted. And thank you for that. Let's see. Thank you for your comments, Cesar. And if you've had enough of me today, tune out what I'm going to say next. But if you haven't had enough of me, you can come back this afternoon. And I'm going to be doing a session on close reading. And I'm looking forward to that. That'll be 2:15 this afternoon. So I hope to see many of you back this afternoon. So we're gonna have some fun. I love close reading. That's awesome. Let's see, Sarah's gonna incorporate science experiments. Awesome. Good deal. Good deal. Anything else as we reflect? Jane says, yeah, incorporating science into math. Beautiful. Beautiful. Yay. All right. Then you're welcome. I'll take the thank you with 2 exclamation points any day of the week, especially on Friday.
Yeah, and keep them coming. And I'd like to just take this time to thank you, Steve, for presenting for us. As you said, you will be back this afternoon at 2:15 for the close reading session. Our next session with Connie Rivera will be at 12:45. So hopefully we'll see some familiar faces there as well. And just thank you to everybody. If we're not going to see you again, have a great rest of your Friday and a great weekend. And once again, thank you so much for your time today, Steve, and we'll see you back in a little bit.
Sounds good. Thank you, everyone. Hope to see you this afternoon.